Particular talk, we're going to have a look at our second part of architectural design. Herein we're going to pick a simple game and have a look at how we can start that process of modelling the objects we have inside, of looking at what those objects do, and breaking up what is a sort of a single notion into lots of different component parts, which is going to help us then refine things to the level where we can introduce some code behind it and start bringing it to life. The game we're going to look at is a classic, Space Invaders. It's a very simple game, but it's a good one to start with, and it's hopefully one that everybody is familiar with. For Space Invaders, and you can see here we have one example of Space Invaders. There's lots of different variants and versions of it. So what are we looking at here? So if we go through this, we can identify that we have some background to the screen. It's a dark screen, but nonetheless there is some background elements to this. If it were playing, you would imagine this by way of having a mountain range at the bottom, and then let's say a scrolling screen on the background to give a little bit of visual variety. We also have game objects, and a number of them are circled here in terms of the bases at the bottom, the player ship and the missile that's been fired. We've got a couple of different types of enemy in the mothership, and sort of a missile coming down from the enemies. We have overlay information displayed at the very top in terms of the number of ships that we have and the score that we're currently on. And there's some decorative effects. So here we have an explosion happening, being appeared on screen. Alongside that, there would be sounds being played as well, but we're not really going to be that bothered about it. So we'll largely focus on this in terms of the objects and maybe the graphic side of it, but we would be cueing and triggering sounds as appropriately. Now, there's an important aside here. Space Invaders, it is a simple game. It's a reasonably well understood game. And what I will be showing you in the next couple of slides is one possible model for it. In all of this, we're not really exposing the fact that this tends to be a highly iterative process. It's not one where you say, okay, here's my game, and then you jump to, well, there's my design, done and dusted. Most often, you iterate through it multiple times. You will go through first of all and you'll say, okay, well, I definitely have these objects. You'll create those ones. You'll have a stab at doing them. That'll change over time. New things will go in, things will come out, things will change. So whilst we're going to show, if you like, one example, for yourself, do expect it to be a highly iterative process and one that will change. And you should welcome change to it because you are refining, you're developing, you're improving your design, and that's no bad thing. So let's start off first of all. We're going to try to identify the objects that we have, and we largely did that in the previous slide, but we'll just relist them here. So we have core objects, things that are essential to the game. So we've got the player ship. We've got a couple of enemy ships. In Space Invaders, in essence, these things, they may look differently, but they don't behave differently. So in this sense here, that we're going to create them roughly as the same object. Depending upon the design that you're doing, you could decide, actually, no, they should be created differently. They should have different properties, and it could be the rate at which they fire, the accuracy with which they fire, how much health they have, whatever you want to do. We've got our mothership, here's the top and moves across. We've got the player's missile that travels up from the player. In terms of the actual Space Invaders game, one of the nice aspects was that you could only have one player missile on screen at a time. And as soon as it hit something or left the screen, you were able to create a new one. So it's a nice little mechanism that encouraged the player to make every shot count by way of hitting something, and had a small penalty. If you missed, you had to wait until the missile left the screen before you could refire. We have enemy missiles that comes down from the sort of the fleet of enemy ships that are moving down the screen. And we've got the base at the bottom, which a couple of different components. You have the main base, but we also had a shield around it that would be slowly eroded as it got hit by each of the different enemy missiles, or indeed the player's missile if the player wanted to shoot through it. Temporal objects, things like our explosions. So they are things that appear on the screen for a certain period of time. They play the explosion through and then it disappears. But we'll want to model those certainly within our game. And overlay objects, so things that are not really the objects involved within the game, but they provide very important information in terms of the number of lives the player has and the score the player has. And here, it's just information that we are displaying to the player. Decorative objects then is our background layers. In this particular case, you can have as many decorative effects as you want. So, first phase in all of these design ones is to list all of the different objects that you believe you will have within your game. The core ones, things that may be temporary objects, things that will be overlay informational objects, things that will be decorative objects. And to come up with as comprehensive a list as you can, but certainly capturing the most important ones. And as we talked about in the last lecture in this series, then you start the process of refining those, of thinking about, well, what properties should they have? How should they behave? Assuming you've done that, there'll also be opportunity to think about how these objects are related together through, in this case, inheritance. And the comment over on the left is quite appropriate. There are lots of different ways you can group objects together. It's rare to have a circumstance where there is one correct or one best way. So it's all about asking, okay, if I combine them in this way, what benefit will it provide me? And where things provide a sufficiently good benefit to make it worth your time to put in the time and hassle to do this, then group them as such. So I'm going to show you a few potential hierarchies here. But they are only potential. I mean, you can do your own one, and I would actually argue these are not necessarily the best ones either. So one view is to have a rather complex setup, as you can see here, where we're saying that all of our game objects, or most of them other than the base, they're all types of sprites. They're things that have a visual appearance that can move about on the screen. So we could extract out these commonalities about the display, the position, the velocity, if you like, by which it's moving, and incorporate those within a sprite object. We could then also define a missile class with a couple of subtypes, alien missile and player missile. Now, if you wanted to, you could just have a missile class, and to say that the missile class, you can have a couple of different images that you would use to differentiate and has a direction. Functionally, otherwise, it's the same. Or if you want, you could group those together within their own respective subclasses. We could define an AI-controlled class for alien ship and our mothership. For the simple game, you may or may not want to do that. If you wanted to have more sophisticated behavior or motions for the ships, and you don't really have it in Space Invaders, but the other sort of top-down shooters might have, then it would be useful, I suppose, to extract out some of the AI-controlled components. And finally, we've got our player ship as well. So one possible grouping. There's another possible grouping. We could say that, okay, we've got lives and scores. They're both types of overlay objects. So let's create an overlay object class to group them together. One possible reason why you might do this is that if you had multiple overlay objects within your game, you could group them together into a collection of overlay objects with a similar interface. And then to update them, you just step through that collection and ask each of your overlay objects to update and to draw itself. So reasonable thing to do if you could have multiple overlay objects, or if the overlay objects are likely to change depending upon the phase of the game you're in. Finally, we could say, okay, explosion is a type of temporal event. So here we're creating something that we will bring into existence. It will exist for a period of time and then disappear. We may store it within an object pool. Explosion, obviously, is one example of it. We could also have splash messages if we were looking at putting some extension into this. So where we have something that again, a message appears in the screen. Next level, game over, wherever you fancy. So lots of different opportunities here, but you are wanting to take your objects and to think about how could we group them together? And in particular, asking yourselves, why would we want to group them together? What is the benefit we're going to get out of this? And like I said, you're looking for benefit. For this particular one, there's no overly complex groupings in terms of the data structures that we might use. So Space Invaders is fairly straightforward. So we could say that the actual game will live within an invaders layer, so we'll group it within that. We might have a separate layer for our menu. Within that invaders layer, well, we'd like to have one background, one life, one score. So we don't really need groupings of them. We could simply go for a dynamic array of bases, alien ships, and alien missiles. And now, I mean, the bases is generally a fixed number. Now, you could differ from one level to the next, but an array is going to be perfectly fine for it. The alien ships are our largest collection, where we might have, say 50, 60 of them available. And we would be removing the ships from that as the game plays on. So an array is a perfectly okay thing to do. You need to think about how frequently we're going to be removing it. And you might say, well, we'll remove a ship once every second. We'll take a ship out of it. Every second would equate to maybe once every 50 frames. So for 49 out of 50 frames every second, we'll just simply be updating the positions of the objects within it, and every once in a while we'll be removing it. So something like dynamic array would be perfectly fine for the frequency with which we would be thinking that we will be removing objects from it. Likewise with the alien missiles, here we would be adding and removing objects to it. We might add 1 or 2 missiles every second. We might remove 1 or 2 missiles every second. So roughly once every 30 frames or 25 frames, we would be changing that particular collection. So again, a dynamic array is perfectly fine for easily managing that. For things like our mothership, or player missile, 0 or 1. So we could arguably not have one of these available on the screen. So the mothership, sometimes it'll be there, sometimes it won't be there. Same with the player missile. And same with the player ship. Most of the time it is there until the game is over, in which case it would be disappeared. For updating drawing then, so we've gone through and we've thought about, okay, what objects do we have? How can we define them? How might we group them through inheritance? How might we group them within collections? And if you like, that gives us our sort of model of the world within which we're operating. All the objects, how they're related, how they are grouped. Next step after having done that is to think about how we might update and draw those objects so that we bring our game to life. So let's look at our invaders layer then. We might have 2 phases, say first one, update, next one, draw. And within update, we're basically going to go through each of our objects and to ask, in essence, how do we update them? What should they do in each update tick? And if we have our background as the first one we pick, for example, we could simply say, well, we'll just scroll the background. So whenever the update happens here, we'll work out how much time's elapsed and then scroll the background by an appropriate amount. If we're updating the player ship, we might think, okay, well, we need to get input. Say if the player's provided us with any input. We need to update the position. We need to check to see if the player's indicated that he or she wants to fire. Now, you'll notice here that I haven't said we should check to see if we've collided with anything. And you could put it in at this point. When a collision happens between 2 objects. So for example, one of the alien missiles and the player's ship could collide. And you've got a decision then. You don't want both of them to be checking for this. You've got to decide, well, who will check for this? And you could decide, well, it's going to be the player that will check to see is the player colliding with any of the missiles. Or conversely, you could say, let's look at each of the missiles and ask, has it collided with the player? Either option is fine. And you could put it down wherever you want it to. And arguably, if you're just doing this in terms of background player ship, you might initially put it into the player. I haven't put it here. I've actually put in with the alien missile. There is a reason for that, but it comes down, we'll talk about it when we get onto the actual missile itself. So updating the player missile, first of all, we update its position, so it's moving up. We remove it if needed, so in other words, if it's left the screen, we get rid of the thing. And we check for and we resolve collisions. Now, there are several things that the player missile can collide with. It could collide with the base. It could collide with one of the enemies in the fleet, or it could collide with the mothership. And because there's these several things that it can be colliding with, and sort of just grouping that up all within a sort of check for and resolve collision. So if you were thinking about this as how you would unpack that if we had more screen space. Updating the mothership at the top, move and appear. So sometimes it's there, so we'd have a chance of it appearing each frame if it isn't. If it is there, simply moving across the screen and then disappearing whenever needed. Updating the alien ships then, they move across the screen and move down the screen depending about where they are. So each ship will move in information, and again it's going to check to see, do I want to fire? If I do, then let me fire. And updating the alien missiles then. So we've got a number of things here. They update their position. They will check and resolve collisions. So here we're checking to see, well, have we hit the base or have we hit the player? And because there are multiple things it can collide with, it can be cleaner from the design perspective to group all of these things together within a sort of the check phase for that. And that's why when, as opposed to the player checking to see if it has hit the missile, it was brought back to the missile class so that it can check to see, okay, out of all of the things I might want to collide with, let's check all of them. We've also gone into the bottom of trigger. This is the first trigger we've put into the space that we have available. So remove if needed, and we've got to check down here that if we have collided with the player ship, then we want to take some subsequent actions beyond that. So we want to remove a life, we want to trigger a respawn or game over screen depending upon what happened. So we're devolving it a little bit further. And if you think a little bit more closely about this, you actually see that we, for some of the other activities above, could also put in these trigger points. For example, when we're updating the player missile, we could check to see, have we collided with the last opponent that's on the screen. Now that could either be one of the fleet or one of the mothership if it's appearing. In that case, we would be triggering the next level. So not much space here by way of putting this in, but by way of going your design, this iterative stage, you would be updating it as these sort of things occurred to you. Finally down here we update the score. So once we've gone through, we've checked to see what have we hit, we're in a position where we can update the score. So we'll do that at the end. For drawing it then, all we need to say is, okay, what order do we wish to draw the objects in? So draw the background first of all, then on top of that draw the bases, the ships and the missiles. Notionally they're all the same height up, so we're not really worried, they're just all drawn. Draw the explosions, and then very top draw any of the HUD elements that we may want to display. So we've taken the game and we've tried to describe how we play Space Invaders in terms of the objects that we've identified and what those objects do by way of update or by way of drawing. It's very much a first stab, but you can see from this that we have had a reasonably good attempt at describing in more detail, in terms of a number of phases or steps, how it is we can play Space Invaders. And you would want to repeat that process until you get down to a point where, for example, scroll background at the top. If you can say, scroll background, okay, I've got the objects loaded in, I know how I would scroll the background, then you can write some code that does that. Equally, for getting input, you can write some code that gets the input from the player. So it's down at a level where you can almost start coding up these different aspects. And as long as you put them together in the sequence that you've designed, then your game of Space Invaders ought to come alive, or to life. So your turn now, and we'll do this in class. So PacMan is another simple game, quite an enjoyable one. If you wanted to do the same thing, well, let's take 20 minutes of your time to go through and to do this. So we've got a screenshot of one version of PacMan. Have a think, maybe take roughly 10 minutes for each of these different phases. What objects do we have here? What objects are needed to model the game of PacMan? So what ones can we see on the screen? Have a think about, is inheritance involved within this? Or what types of data structures are going to be involved within it for storing the objects to enable us to manipulate them easily? For the update process, again, take another 10 minutes in this. If we were to go through specifically the updates, I mean, draws are going to be reasonably straightforward. But thinking about the update, so if we're running it at 30 or 50 or 60 frames per second, for each of those objects that you have identified, what would they do on each of their update turns? So produce a simple series of consider this, do that. It is actually worthwhile doing this here because in doing so, you will have some experience or some more practice of this process of architectural design at a high level. And having done it for PacMan, I then suggest that in your teams, you do it for your own particular game. And there take a bit longer by way of going through the steps of recording things down, of revisiting it and sort of slowly developing it over time. So in terms of key takeaways for this particular one here, there's only one. What we're doing here is very simple. We're taking a complex thing, a game, and we're breaking it up. We're trying to model the different elements. We're trying to model what those objects do and how they are related one to another. It's divide and conquer, simple as. And it is the essence of all forms of software engineering. It doesn't make any distinction if it's a game or something else. This is how we actually create software.